Hey guys, Mr. Backerberg here. In this video, we're going to look at graphing linear inequalities. When we're graphing out an inequality, there's a few steps that we're going to follow. And step number one says that we want to get our inequality to look something like a y equals mx plus b equation. Now, it's not going to look exactly like y equals mx plus b because we're not going to have an equal sign in there. We're going to have a different inequality symbol. It could be a less than, it could be a greater than, but it's definitely not going to be an equals to. Then step number two, based on the inequality that we get, we want to graph out what's going to be called our boundary line. Now that boundary line is going to look a little bit different depending on what kind of inequality symbol we have in our inequality. If we've got just a less than or just a greater than symbol without the equals to line underneath it, we're going to graph out a dashed line or a dotted line. But if our inequality does have the equals to line underneath it, then we're going to graph out a full solid line. Once we have our line graphed out, what we want to do is test out some point that doesn't lie on that boundary line. And we want to check if that point or if that ordered pair is a solution to the inequality. So we're going to take the x and the y value from the ordered pair, plug it into the inequality to see if it works or not. And then our last step here, we're going to do a little bit of shading. We're going to shade the half that contains the point if the ordered pair is a solution, but if the ordered pair is not a solution, then we're going to shade the other half. So for this first example, we've got the inequality y is greater than 4x minus 3. Step number one says that we want to get our inequality to look sort of like a y equals mx plus b equation. And that's what we've got happening here. We don't have an equal sign in there. We've got that greater than symbol, but this equation still sort of has that y equals mx plus b look to it. So now what we're going to do is start plotting this out. So we can see that the b value on the end is negative 3. And remember that b value is your y-intercept. So that means that this graph is going to cross the y-axis at negative 3. Then we've got a 4 in front of that x, and I'm going to take that 4 and put it over 1. That's our slope. So I need to go up 4 spaces and over 1 space. So from that y-intercept that we plotted out, I'm going up 4 spaces and to the right 1 space. So I'm going to use those 2 points to help me draw my line. Now looking at our inequality, it's just a greater than. It does not have the equals to line underneath it. So when I graph out my line, I need to graph out a dotted line or a dashed line. So there's our boundary line for the inequality. Now step number 3 says that we want to pick an ordered pair that is not on the boundary line and test it in our inequality to see if it works. And a nice point to always use if it's available to you is the origin 0, 0. So this boundary line does not go through the origin, so we can test out the point 0, 0 to see if it works. So we've got an x value of 0 and a y value of 0 that I'm going to plug into my original inequality. So we would have 0 is greater than 4 times 0 minus 3. And now we want to simplify this down to see if it's true or not. So 4 times 0 is 0. So we get 0 is greater than 0 minus 3. And then 0 minus 3 is just negative 3. So 0 is greater than negative 3. And we want to decide, is this true? Is 0 bigger than negative 3? And the answer is, yes, it is. So we tested out the point 0, 0, and it worked in our inequality. So step number 4 said if that point works, then we want to shade on the same half as that point. So because 0, 0 worked, then we want to shade on the same side as the point 0, 0. So what's happening is every single point on this half of that boundary line would work if we plugged in the ordered pair to our original inequality. Now as we take a look at our next example here, we've got 3y is less than or equal to negative 2x plus 15. Step number 1 says that we want to get our inequality to look like y equals mx plus b. So we've got that 3 that's hanging out in front of the y that we're going to have to get rid of. So 3y really means 3 times y. So to get rid of that 3, what we're going to have to do is divide everything in here by 3. So when we do that, we're going to get y is less than or equal. Now we can't take negative 2 and divide it by 3, so I'm just going to leave it as a fraction, negative 2/3 x. And when we take 15 and divide it by 3, that's going to turn into plus 5. So we get the inequality y is less than or equal to negative 2/3 x plus 5. So now that we've got it sort of looking like y equals mx plus b, now we're going to graph this out. So the very first thing that I see is we've got a b value of 5, meaning that our y-intercept is up at 5. The next thing I look at is the number in front of the x, because that's our slope. We've got negative 2/3. So I'm supposed to go down 2 spaces and over 3 spaces from that point that I just plotted out. So down 2 and to the right 3. So there's my second point. Now I want to take those and connect them with my boundary line. If we look at our inequality, it does have the equals to line underneath it. So when we graph out our boundary line, it's going to be a solid line. Now step number 3 says we want to test an ordered pair that's not on the boundary line. This line does not go through the origin, so it's going to be safe for us to test out 0, 0. So I'm going to take an x value of 0 and a y value of 0, plug those in here to see if they work. So we get 0 is less than or equal to negative 2/3 times 0 plus 5. So negative 2/3 times 0 is 0, so we get 0 is less than or equal to 0 plus 5, and 0 plus 5 is just going to give me 5, so 0 is less than or equal to 5. And again, we're trying to decide if this is true or not. Is 0 less than or equal to 5? And yeah, 0 is less than 5. So 0, 0 works in this inequality. And step number 4 says if the point you test does work, then you want to shade on the same half as that point. So 0, 0 worked, so we want to shade on the same half as that point 0, 0. So again, just like we talked about on the last one, that point working means that every single point on this half of our line would work in our inequality. As we look at our next example, we've got y is less than or equal to 3. Step number 1 says that we want to get our equation to look sort of like y equals mx plus b. Now what I notice in here is that we don't have an x value at all. So if we want to think about it this way, not having an x value on the right-hand side is really like having 0x over there. And 0x, or having a slope of 0, that's a special kind of line. And when your slope is 0, that means that you've always got a flat horizontal line through whatever your y-intercept is. So in this case, because we've got that plus 3 on the end, that's our y-intercept. So we've got a y-intercept at 3, and because the slope is 0, that's going to be a flat horizontal line. Now, as we look at our inequality, it does have the equals to line underneath it, so this is going to be a solid horizontal line through that y value of 3. Now, we want to test out a point to see which half we should shade on. Again, this one does not go through the origin, so it's going to be safe to test out 0, 0. So we've got an x value of 0 and a y value of 0 that we're going to plug in. So 0 is less than or equal to 0 times 0 plus 3. Well, 0 times 0 is 0, so we get 0 is less than or equal to 0 plus 3, and 0 plus 3 is just 3. So 0 is less than or equal to 3. And we're trying to decide, is this true or not? Is 0 less than 3? And the answer is yes, 0 is less than 3. So we want to shade on the same side as the point 0, 0. So just like we've seen before, because 0, 0 worked, that means that every single point on this half of that boundary line that we drew out would also work when we would plug in the ordered pair to our inequality. In this example, we've got 2x minus 3y is greater than 9. Step number 1 says that we want to get this to look sort of like y equals mx plus b. So the first thing that I notice is that we've got that 2x on the left-hand side, and we need our x to be on the right-hand side. Because it's a positive 2x, in order to move that over to the other side, we're going to have to subtract 2x from each side. So that's going to leave us with negative 3y is greater than negative 2x plus 9. Now we want to get y all by itself, and right now we've got that -3 attached to it. So that really means -3 times y. So we're going to divide everything in here by -3. Now we have to be really, really careful when we're dividing things, especially if we're dividing by a negative number. When you multiply or divide by a negative number, you have to remember to flip your inequality symbol around. So that greater than symbol is going to turn into a less than symbol. So we're going to get y is less than. Now when we take -2 and divide it by -3, negative divided by a negative turns positive. We can't reduce down 2/3 at all, so I'm just going to leave it as positive 2/3 x. And when I take positive 9 divided by -3, I get -3 as my answer. So now I've got everything I need in order to be able to plot out my line. So first I look at the b value on the end. It's a -3, so I'm going to go down 3 spaces from the origin to plot out my y-intercept. We've got a slope of 2/3, so up 2 and over 3 from that y-intercept that we just plotted out. Now we need to draw on our boundary line, so we look at our inequality symbol. It's just a less than. It does not have the equals to line underneath it, so we need to graph out a dotted line for our boundary line. Now we need to pick a test point that we can plug into our inequality to see if it's going to work or not. This line does not go through the origin, meaning that it's going to be safe for us to test out the point 0, 0. So we've got an x value of 0 and a y value of 0 that we're plugging in. So 0 is less than 2/3 times 0 minus 3. Well, 2/3 times 0 is 0, so we get 0 is less than 0 minus 3. 0 minus 3 is -3, so we get 0 is less than -3. And we're trying to decide if this is true or not. Is 0 less than -3? And this time the answer is no. 0 is not less than -3. So step number 4 says if the point that you test out does not work, then you want to shade on the other half of your boundary line. So 0, 0 did not work, so we need to go to the other half of the boundary line, and that's where we're going to do our shading. That's going to be it for this video. Thanks for watching.